Alrighty, a little late in the day, but still gonna finish this, hopefully pretty quickly. It's easy to sort integers by the number of 1 bits. Bunch of bit operations or bit analysis problems recently. You're given an integer array. Sum of the integers in the array. Sort the integers in the array in ascending order by the number of ones in their binary representation. And in case of 2 or more integers have the same ones, you have to sort them in ascending order. Return the array after sorting. Okay, so increasing number of ones. Tie goes to the smaller value if you're ascending. No, actually, never mind. Case of 2 or more integers have the same ones, you have to sort them in ascending order. So 0 in ascending order, I see. So 0 is obviously going to be first, and then 1. Okay. 1, 2, 4, 8. And then for 3s, it'd be 0, 0, 1, 1. Or for 2 1s, 2 set bits. And then it'd be, I think, 1, 0, 1, which is 5. 1. Did I do this wrong? 1, 2, 4, 8. Oh no, can't be there. 1, 1, 0, 7. Okay. Wait, that's not right. This is 3. This is 5. Oh, I'm missing one. I'm missing one. 3, 5. This is 6. Oh, this 3, 5, 6, and 7. Oh, okay. Wow, that took a long time. So what is the input? The input is the array itself. I see. I mean, I guess you could make the string representation of it, and then sort that. String representation of the binary, sort that, convert it back into binary. I wonder if there's a pattern here that I should be going for. So the issue is this thing is not necessarily like a range of values. It's just random values that you can have. So I mean, I guess I don't think you can just kind of, yeah. I mean, would you have to convert? I mean, you can go through each value and then go through each value, count the number of set bits in it, bucket that. So count all the ones that have 1 set bit, 2, 4, 6, 2, 4, 8, 1. All have 1, 1 in their binary representation. Then you still have to sort that now. And if there's more than 1, then you have to do even more processing. Okay. Alright, I'm just going to go with converting it to binary. So for Python, that would be, so here I'll just convert each value, kind of each integer value into binary string. Yeah. Oh, yeah, interesting. I do need a bucket by the number of set bits in it. Okay, so let's go ahead and say I'll have a buckets, and this will be a default dictionary list. The key will be the number set bits, number ones, and the value. So here, could also make this a 2D array, but I think this is probably actually maybe making this a 2D array is probably it might be better actually. So I guess maybe index equals the number of set bits, and the value is the list of strings, binary strings. So buckets, I mean, I know, I assume this can be up to 32 bits because it's integers. Well, I'll say the value in the array is 10, up to 10 to the fourth. So actually it's not 32, it's probably like 5, no, not 5. 10 to the fourth is like 10,000, so maybe 10-ish. No, 10 is 1,000. 10, like maybe I'll just say 15. There'll be list for everything in range 15. So for every value in the array, let's say the set bits is going to be, or the count of the number ones is going to be value dot bit count, I think is the thing. I think it's called bit count. Yeah. And then buckets at this count is going to append the string. So bin takes in the integer and returns the binary string with 0b in front. So it's going to be bin of the value bracket from 2 on, slicing it from second index on. And then I think that's it. I'll have my answer array. I'll need to sort all the list for every B list in the buckets. I think it could be none. I think if B list, which means that it has anything in it, then maybe I'll say if the length of B list is greater than 1. Then B list dot sort. Then I need to convert it back to the integer, don't I? So maybe I need to have a tuple. Maybe I need to have a tuple. You can also just do a default dictionary storing the string with the value. Yeah. Okay, I think I'll just have a tuple. List the binary string, so the binary string and then the value itself. So here it should be answers empty for every B list in buckets. If and then for every kind of tuple tup in the B list, the sorted B list now, it'll be answer append the second value of this, which is going to be the actual integer value. Tup is not defined. Oh, whoops. If, no, I meant for. Interesting. 1, 2, 4, 8. It had 3 and 5 in the wrong order. 3 and 5. Okay, let's go ahead and just print out the B list here. Zero, zero, one. Sure. Ah, ay caramba. Yeah. It's not counting the leading zeros correctly. So I think it's going to be, what was that second part? It's going to be slicing it to do something, and then I think it's something called z length, z fill. I think it's z fill. Which is the pen leading zeros. What was the z fill? Z fill. What's the parameter there? Is it just the number of overall size of the string? Yeah. So z fill is gonna, I guess I'll make it 15. Okay. So I'm pretty sure that should work. You see 2 to 15 should be bigger than 10 to the 4th. Or else you log base 2 of 10 to the 4th. What is it? 13, so I can do 14. Alright, 15's whatever. Close. Okay, I think that should work. This probably should be like range 32, just to make it consistent with all 32-bit integers. Not very fast, is it? Not very fast. I think maybe I wonder if I can use sort passing in a key. Where the key is the string value. Yeah, I think maybe that's probably better, right? Append just append the value to the list. And then use the key parameter sort. So key equals lambda x, where x is based on this. X is the binary, the string of x. Ignoring the 0b in front, z filling to 14. I think this should probably be fine for every. And here it's just going to be appending the actual value itself. Oh, even slower. Well, I mean, I think this is overall better than using tuples. Interesting. All enters in the ones. Just sort them in ascending order. I wonder. You have to use the sort function, right? Probably. I wonder how costly the z-fill is. I could make it lambda x, where x is based on the length, and then tie break based on just the binary, not having to do with z-fill. Wonder. I think this would be even worse, but no. Doesn't work. Lambda x. Because I would need to have the binary string. Yeah, I don't know about this. Easy, you say? Easy, you say? One. How many numbers are there? Actually, what if I just use multiple? What if I used a single sort call passing some very special key? A single sort call passing a very special key. So array dot sort key equals lambda x, where that's gonna get you a tuple that is first sorted by x dot bit count. I see. And then the second parameter is this. Okay. That does remove a lot of overhead. Okay, I got 3 milliseconds. I wonder if the Z-fill, is there a way to, so you tie break based on the number of bits that are on, and then second tiebreaker should be like the length of the string, the number. Can you just tie break on the bit count? Yeah, you have to have Z-fill in order to get the leading zeros to count. The ones with more leading zeros. So I mean, maybe do the length of the bin of x. I don't know about this. X up bit count, sort next by the length of bin of x, and then finally the bin of x from 2 onwards. Got a closing parentheses. Length of bin of x. Yeah, okay, another closing parentheses. Do 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 do. Back to slowness. All right, I'm done. Okay. Skipping overhead of the below of the longer version using more info in the key, in the lambda key when sorting. All right, I'm done. So let's go there. All right, so the summary here is, wait, double check the random runtime. Is it still, wow, that is still very random. I guess maybe it's just all pretty random. I mean, it's the same code, right? It's just one single line. Okay, yeah. All right, summary. This is going to make use of the key parameter when sorting lists in Python. In particular, can use a lambda function on the value to create a tuple, to create a tuple kind of sorting key that gives all the sorting kind of breakpoints, sorting comparisons, all the comparison points. Basically, the sort needs to be first. The values are first sorted by the number of set bits once. Thus use bit count as the first parameter, first parameter in tuple. Secondly, needs to sort by the I guess it'd be lexicographical string version. So convert to string and with appended leading zeros to do that. Yeah, so the number of bit counts of all the zeros come before all the ones, come before all the twos, in terms of having some number of bits being on. And then bin converts it to binary string, slicing 2 onwards from in that string because index 2 onwards in that string, because when you convert binary string it's going to be 0b and then some 101 whatever binary values. And then zfill is to append the leading zeros because you have ties. You have to have leading zeros to have correct tiebreakers. Let time complexity be O of n. No, sorry, this O of n log n, since using sort function. And there's constant overhead in converting values to key tuples for sort. Like, it's not going to take that long to create this key. Space complexity is going to be O of 1, since no extra space is needed. Alright, cool beans, cool beans.